Hi, in the last session, we completed the VHDL code for shift register and tested it using test bench. Now we will design synchronizer module for our UART receiver. If you remember from the UART receiver block diagram, then this synchronizer is placed just before the shift register. And the synchronizer will take the input signal from the receiver and it will synchronize that input with the system clock frequency, and then we will pass it to the output. So in reality, output of this synchronizer is exactly same as it received at the input, right? But our synchronizer output will be delayed by the two rising edges of clock frequency because we are going to design a two-stage synchronizer here. And for this, we will use two flip-flop. So during the first rising edge, our input will pass through the first flip-flop. And during the second rising edge, our input will pass through the second flip-flop. And the output of second flip-flop will be our final output. Okay, so let's write the VHDL code for this.
Okay, so let's open the Notepad++ once again. So first we will create a new file. So click on this new file button. Now save this file as .vsd. So save as. Now this time we are going to design synchronizer for our UART receiver. So we are going to save this file in the source folder, right? So give it some name. Suppose this is sync. Now select the file type. VHDL file means basic hardware description language file. Now click on save. First give the library declaration and entity declaration. So let's copy this code from here and now paste it here. Now this is sync, so entity name is sync. So update this. I will define the generics little later based on our needs. Now we have this port declaration. So we are required this clock and reset signal as an input. So these are okay. Now we need one input as an DIN, which is asynchronous in nature, and we will have one output which will be the synchronized version of our DIN port, right? So suppose the input port is async, so that is asynchronous, and output is sync out. Okay, so sync out is our output port. Okay, so this is output. Okay. So this is our entity declaration for this sync module. Now architecture part. So architecture behave of sync is now begin and in the last and architecture. So and behave. Okay. Now we are going to design this synchronizer as a two-step synchronizer. Okay. I already explained in our previous sessions that why we are going to design this two-stage synchronizer here. Okay. So for this synchronizer, we will use registered process block. So first we will write the structure for this registered process block. So write it sync process, and that is a process having the clock and reset in the sensitivity list because this is a registered process block. Now begin. If reset is equals to 1, then do something. Else if rising edge of clock, then do something, and in the last and if and process. Okay, so this is the basic structure of registered process block. And now because we are designing a two-stage synchronizer, so we are needing two internal signals because it will generate two flip-flops connected in the series manner, right? So let's create one signal that is having two elements inside it, or even you can create two separate signals as well. Okay, so what I will do that I will create one single signal, and that will be std underscore logic underscore vector type and having the range of 1 down to 0. So we have two elements inside this signal, right? So what will happen that if reset is equals to high, then SR will be logical high on all of its elements, right? So others having the value of 1. Now why we have used 1 here? Because as per the RS-232 protocol standards, we are supposed to get logical high when there is no transmission happening. Means when it is in idle state, it will get logical high. Okay. Now it's possible that in your project, when you are not using RS-232 protocol and you are sending logical low at the ideal state, then you have to change this reset condition to 0, right? So instead hardcoding 1 or 0, I will prefer to use generic here so that I can use the same code in different application using different protocols. Okay. So what I will do that I will create a generic named as ideal state and I will move that value into this SR signal. Okay. So suppose this is ideal state. Now I also need to define this in the generic section, right? So this is ideal state and that is std underscore logic type. Okay. Now what will happen when reset is not asserted, right? Now because we are designing the system in two-stage synchronizer, right? So at the very first rising edge, after this D input is captured, means this async signal is captured. So at the first rising edge, this will be captured by the first element of this SR signal. So SR0 will capture this async signal, right? And for the next rising edge, this SR1 signal will capture the SR0 signal, right? And that's it. So what these line of codes is doing that when reset is high, you will be getting the ideal state. Else for the first rising edge, when this async is captured, so at the first rising edge, this data will move to the SR 0th index, and for the next rising edge, this SR 0th index will move to this SR1 index, right? So this SR1 index is actually 2 clock cycle delay of this async, right? So in the last word, I will do that I will move this SR1 signal into our output. Okay. So that's complete our two-stage synchronizer. And now this is the time to compile our code and check for any syntax error. Okay. So let's save this. Go to this model sim simulator. Now go to this project tab, right click, add to project, existing file. Now click on browse, go to our project. Now select this source folder and we have this sync module inside it. So just open it, click on OK. Now right click and compile. Okay, so compile selected and you can see we get the message compile of sync.vsd is successful, means there is no syntax error. So this is the time to write the test bench for our program. Okay.
Okay, so that was our synchronizer module for UART receiver. Next, we are going to write the test bench for this module and we will simulate it. So stay tuned for the update and thank you for watching.